What's up guys, my name is Amir and welcome to Electrical Infinity. In this video, I'm gonna explain you about cable tray sizing in a manner approaching standardizations for tray layout. Cable trays are used as a basic support system for power, control and signal cables. This support system is used in both indoor, outdoor, dry or wet conditions. Calculation of cable tray sizing involves 4 steps. The first step is to determine the cable's diameter. The second step is to calculate minimum required airspace between single conductor and multi-conductor cable. Also to design a cable layout to maintain required airspace between cables. The next step is to determine the minimum width of ladder tray. And the last and final step is to consider the thermal expansion and contraction. Now let's focus on first step, which is to determine the cable diameter. In order to do this, we need two formulas. First one is area of circle, A equals to pi r square, and second one is diameter of circle, which is D equals to 2r. And we are using here 300 square mm 3.5 core 4 run wire. So this is a 3.5 core wire, which is 3 core, and 0.5 is for neutral, and a 4 run wire. As you can see here in the cable tray, I am using a 4 run wire. So the first thing we need to find for the cable is radius. So from the formula A equals to pi r square, we get the value of radius as r equals to under root of a by pi. Substituting the values, we get the answer as 9.77 mm. So the radius of each conductor is 9.77 mm. So D equals to 2r is the diameter formula for the conductor. So D equals to 2 into 9.77 mm. So D equals to 19.549 mm. As we know that we are using a 3.5 core wire, so we need to multiply this by 3.5. So 19.549 into 3.5, which give us a value of 68.42 mm. So this is the diameter of this cable, 68.42 mm. Now let's get right into the calculation of minimum required airspace between single conductors. So before that, please make a note that the airspace between conductors should not be less than 25% and more than 100%. So as we know that our conductor size diameter is 68.42, we are using a 3.5 core 4 run. So these are the 4 run wires, A, 4 A's, and the distance between them is X. Please note this as X. So the 4 runs and the distance between them is X. Calculating the value of space between these conductors is very easy. So X between A to A is 68.42 into 0.25, which is 25% of cable's diameter. So 68.42 into 0.25 is equals to 17.105 mm. Now in order to determine the width of tray, which is the third step, we need to take the 4 conductors, which is 4 A's, and multiply them with 4, as 68.42 is the diameter and we are using 4 runs. So 68.42 mm into 4 give us a value as 273.68 mm. And in order to calculate the total spacing between these conductors, 17.05 mm into 3, since we are using 3x values, so 51.5 mm is the answer. So the total width of the tray is A plus X, which is 273.68 mm plus 51.5. So this gives us a value of total width of tray as 325.18 mm. These are the standard sizes of cable tray, width and height. So in our condition, since we got the total calculation as 325 approx, so we can use width of cable tray as 350 mm, and we know that the diameter of our cable is 68.4, so we are using here the height as 100 mm. So the final dimensions of tray are 350 mm width and 100 mm of height. So this is the final calculation. The last step is consideration of thermal expansion and contraction. Usually long ladder tray runs are particularly susceptible to extreme conditions of temperature. So different materials have different coefficients of linear expansion. This coefficient should be multiplied by the length of the tray run and the possible temperature variations. The expansion value is calculated from this graph. On y-axis we have maximum temperature, on z-axis we have minimum temperature. So we are drawing a straight line from maximum to minimum temperature, and we are also drawing a straight line from temperature at installation time. So whatever the value we get on x-axis is the value of expansion. So 9.55 mm is the gap setting between two cable trays in our condition. So that's all in this video guys for calculation of cable trays. Also I'm gonna explain you about different types of tray, what materials we use in manufacturing of the trays in our next video hopefully, and also I'm going to explain you about electrical designing. So let me explain you overall the types of cable tray. So there are three types: ladder type, perforated type, and mesh type. In ladder type we are using powder and hot dip galvanized iron too, whereas in mesh type we are using normal and hot dip too. So in indoors we use power coated trays, whereas in outdoors we use a hot dip galvanized iron. Each tray has different pros and cons depending on various conditions. Overall, this is how we calculate cable tray size. I hope that this video was very useful for you to learn electrical infinite. That's all in this video guys. Thanks for watching this video and don't forget to subscribe to my channel Electrical Infinity. Thanks for watching.